Hello, welcome to Civil Tech. Today I'm going to talk about the Atterberg limit calculation. This is Atterberg limit is usually performed in the laboratory for determining the liquid limit and plastic limit of soil. The test instrument directly does not give you the exact result. So after you got some data such as water content and number of flow, you should do some analysis process to find the liquid limit as a final result. Here we have a water content and number of flow. Then we need to draw a graph between the number of flow on horizontal axis with logarithmic scale and water content on vertical axis with linear scale. First I'm going to insert, then from scatter chart. From this or this, you can choose one of them. Then right click, select data, then click on add. For the series name you can write something as you want. Atterberg, for example, Atterberg limit chart. For the x-axis, mean horizontal axis, you should select the number of flow, and for vertical axis, you should select the water content. Now we see the relation between the number of flow on horizontal axis and the water content on vertical axis, but according to test standard, the horizontal axis it should be logarithmic scale. Then I should select this horizontal scale, right click, format axis, then from here, from axis option, take this logarithmic scale. The scale is starting from 110 to 100, then it's okay. For the minor and major grid line we should do some modification because it's not clear here. First I should select this, added minor grid line. Now we are adding the minor grid line, but it's not too clear because of the color. Select again, format minor grid line. Then I can change the color, for example like this, or any color you want. Usually this color is very suitable. For major grid line, from 110, 100, I can choose a darker color, such as black. Same thing for vertical axis. I can add minor grid line. Then I can format the minor grid line as before, like this. If you don't like this minor grid line because this maybe the drawing area, it will be a little complex, you can choose a different color. For the major grid line, I should choose a black. Yes. Then we can do some modification for the scale because as we see the curve is not clear because of too small. If we check the vertical axis, it starts from 0 to 13, but the minimum value for this scale is 22 to 27. Mean if I change this from 20 to 30, then it's okay. Select this, format axis option. Minimum 0, I can write 20 here, 20 to 28. The increment is 0.2, mean each minor grid line is 0.2, each major grid line is 1, 20 to 21, 22. You can change the scale as you want. Then we can make a space here, make a space here, select the chart, then go into design and add the chart element, axis title, primary horizontal and primary vertical. Then here we should write water content in percent, and for this one, no of flow, no of flow. Yes. Then select the chart and change the font because it's a little bit nicer. Here 12 is very perfect for this kind of chart. We can make bold, and it is bold. Now we draw the Atterberg limit chart, but we need to find the liquid limit. Liquid limit is usually the water content from 25 below, but here we see we don't have exact 25. We have 20, 29 and 20 to 31. In between we have 25, but we should do some modification, some interpolation for the numbers. Directly we can do it on the chart. Select this one because the shape of the curve is parabola, not a straight line. We should add it a trend line. Trend line is a straight line between most of the point, as we see here, linear. We should display equation on the chart because we need this equation. This equation we can make some like this. This is the equation of the trend line. Then we should remove this full line. Select this and go to design, change chart type. Here select this. Yes. Then change the color of the trend line to black. It's better. To black color with full line. Yes, like this. Yes. Then we need to, based on this equation, we need to find the new data for water content, because we have a straight line. Now for x mean number of flow because it's on the horizontal scale, y equal to water content because it's on the vertical axis. I can write here water content y and no of flow x. Then because we need to find the liquid limit based on 25 number of flow, we should choose two number between 25. Mean one number should be more than 25, one number should be less than 25. Now I can choose 20 to 29, I can choose 20 to 31, but I prefer to choose 20 to 31. Here 31, here 20. Yes. For y, water content, we should use the equation. First I should enter the equation minus 0.4146 multiplied by x here plus 35.796. Here is the new data of water content. If you look at the data from the previous curve is 22.4, here 22.9. Because we draw a straight line between the point, so the water content made some change, but it's not too much. Same thing for 20, just we should drop the cell here. Now here the water content for 20 in previous is 27.3 and here is 27.5. now we have two numbers between 25. We can make the interpolation here. Liquid limit, go to the formula, find this function trend. If you don't have this function in recently use it, you can search from the function, you can find easily trend. Then we have three fields required to field: known y, known x, new x. We want to find the liquid limit. Liquid limit is a water content, so the y-axis is a water, known y is a water content. I want to find this, the number between this number and this number. That's why I select this. For known x, I have 25 number of blow, which is constant, but I should select two number between 25. From the known of x, I should select this. From the new x, I should write 25, mean between this number, this and this, I have 25. For this 25, find the number between this number and this number. Note that in this case, known y is equal to vertical axis and known x is equal to x axis, but in this case is a special case that almost the axis is equal to the field of the trend line. For different case, maybe it's almost reversed, because for example, when I say I want to find the number of blow based on 26% water content, because now I want to find the number of blow, so known y equal to number of blow, known x equal to water content, new x equal to 26, for example. So choosing this kind of field is not depending on the axis. It depends on which one is a constant for you. For example, here number of flow is a constant because we have 25. We want to find the interpolation of water content. That's why water content should be choosing in the first. So using trend function is depend on the case, which case you have. For this case, I should select this and then press OK. Now I find water content, it's almost equal to liquid limit. For example, for 20 we have this water content, for 31 we have this water content, for 25 between this we have this water content, between 22 to 27. Then I need to draw some line here. We should draw a vertical line here, then intersect it with the trend line, then draw horizontally to indicate that this number is liquid limit. I know the easy way. For this horizontal line, we need 4 coordinate. For this point, x equal to 1, y equal to liquid limit. For this point, x equal to 25, y equal to liquid limit. Now this is the coordinate for drawing 2 points on the chart. And then click here, select, add, this is x, this is y. Now I have 2 points here. I can select them, then go to design, go to this, select this one. Now I have a line, and then select this, format the line, change the color to black. Usually black is used for this kind of things. Here we need the vertical line here, vertical line for this point, vertical line for this point, x equal to 25, y equal to 20, because the lowest point of y-axis is 20. Then for upper point, x equal to 25, y equal to this liquid limit. Now have another 2 point, select data, then add, select this and select this. Now I have another 2 point, then go to design, change chart and select this. Yes, here the line, go to format, change the color to black, then you can choose this here, 25. We have a row here, and then yes, mean from 10, 20, 30, 25 here, 25 to trend line. Then we have water content 25.4%. Then I can move the chart here. That's all. I can make a title here, select design, then chart title. We have here or here above the chart. I can write the Terberg limit. Chart or liquid limit determination or something you want to write here. Thank you for watching. Today we are finished. See you next time. I hope you like this video. Don't forget to share and subscribe our channel. Thank you for choosing Civil Tech. Have a nice day.